How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at molecular shapes and VSEPR, valence shell electron pair repulsion model practice problems. All right, so number one, what are all the possible molecular shapes for a molecule with a generic formula of AB2? So we could have A in the central, bonded to the B, bonded to the B with no lone pairs of electrons, in which case you get a linear molecular geometry. You could have a lone pair of electrons on that central atom, which would then make it bent molecular geometry. You could have two lone pairs of electrons around those central atom, the central A, which is also bent. But really the only shapes that you can get with two atoms bonded to a central atom is either linear or bent. The bond angles may be different, but those are the only two molecular shapes. Number two, what are the possible molecular shapes for a molecule with the generic formula AB3? Let's start with AB3 with no lone pairs of electrons. If we have this shape, the molecular shape would be trigonal planar. It's going to be flat, right? That's what planar is telling us. Or, well, what if we have a lone pair of electrons on that central atom? The electronic geometry would have been tetrahedral, but because we had this lone pair of electrons, it's now trigonal pyramidal. All right, well, what if we put two lone pairs of electrons on that central atom? Now the shape, the parent shape, the electronic geometry would have been trigonal bipyramidal, but because we got these two lone pairs of electrons, it is T-shaped. And then if we had three lone pairs of electrons around that central atom, we're also going to get another T-shaped molecule. It was octahedral, but with three lone pairs of electrons, you end up with a T-shaped molecular geometry. Number three, ClF3 is T-shaped geometry. How many non-bonding domains are there in this molecule? Well, you could just draw it out. You go, I know each chlorine has 7 valence electrons, and then each fluorine has 7 as well. So there's a total of 28 valence electrons. Put Cl in the middle, fluorine, fluorine, fluorine. And when you finish the octets for the fluorines, which I'm going to do sloppily here because who wants to see me draw dots? You will have placed 24 of the 28 valence electrons, which means you have 2 pairs of electrons going on chlorine, the central atom. So how many non-bonding domains are there? Well, there's 1, 2. There's 2 non-bonding domains. No big deal. Number 4, what is the electron domain geometry and the molecular geometry of BrO2-? So same process of figuring out what the Lewis structure is going to look like. You count up the valence electrons, you finish the octet, and let me see if I can jump the gun. Each oxygen has 6, so there's 12, plus 7 from bromine brings us to 19, plus the 1 from the minus gives us 20. So let's see, I've now placed my 20 electrons, so my electron domain geometry. Well, let's see, there are 1, 2, 3, 4 domains, so it would be tetrahedral. But the molecular domain geometry would be bent. There you go. Number 5, determine the electron domain geometry for each of the following examples. All right, so CBr4 is going to be pretty straightforward. We got 4 bonding domains and no non-bonding domains. This shape is tetrahedral for both because there are no non-bonding domains, so it's tetrahedral for both. pH3 is going to look like this. Pretty common shape. Kind of looks like NH3. So the electron domain geometry is going to be tetrahedral, but the molecular geometry is going to be trigonal pyramidal. All right, CCl2Br2 is going to look just like A, except 2 of those Brs are Cls. So it's also going to be tetrahedral for both. And then XeF4, Xe in the middle, 4 fluorines, You go, how many electrons do we have total? 36. So finishing the octet for fluorines brings us to 32, which means we have 2 unshared pairs around a xenon. So the electron domain for this one, well, 6 domains tells me that it's octahedral. But the molecular is going to be square, planar. Right? This molecule is going to be flat. These unshared electrons are going to be at the north and south pole of this octahedral shape, which means if you're looking at just the bonded atoms, it's going to be a flat shape. It's going to be square. 6, which of the following will have bond angles of 120 degrees? So again, you got to draw out the shapes. ClF3 is going to be T-shaped, which means the bond angles are all going to be 90 degrees. So not this one. pH3 is going to be trigonal pyramidal, which is, I think it's like 109.5 degrees. So not that one. BCl3. Well, if we do BCl3, boron is one of those exceptions to the octet. It's going to be trigonal planar, which means it will have bond angles of 120 degrees. So BCl3 is looking pretty good. NCl3 is going to be just like pH3, trigonal pyramidal, 109.5 degrees. So option C. Number 7. What are the bond angles marked A, B, and C in the molecule below? All right, so what they don't show you here, though, is the non-bonding electrons on nitrogen. So if we take a look at A, its electron geometry would be tetrahedral, which means its bond angles are 109.5 degrees. At B, we have a trigonal planar geometry, which tells us we have 120 degrees. And then at C, C is also going to be a tetrahedral geometry, which means that its bond angles are 109.5. All right, I hope you found that helpful. We'll see you in class. Goodbye.